My name is Reiner Schmol. I'm a product manager of Bosch Connected Devices and Solutions. Bosch is a very big company. We have 410,000 people, and this small department, we do things. We do the big T within the whole IoT story. That's what we do. Okay, there is the agenda. Bosch Connected Devices and Solutions, as I already said, what we do. Then we have the cross-domain development kit. That is a very nice universal programmable sensor device. We're going to talk about that. The LoRa extension to that. Tracy, which is a rough environment sensor for building sites. And parking lot sensor, PLS. That's what we do have on the LoRa side in our portfolio. So let's start. That is very fast talked about that story because we are an IoT startup within Bosch. In Reutlingen, in the wafer fab, we produce 1.6 billion of these micromechanical sensors a year. So that's 5 million a day. The first was we put it into the automotive. The next one was the mobile devices, and the third one will be IoT, and that's why we set up IoT devices. And we have these 4 domains, and of course we are using LoRaWAN. I think the heaviest reason is because we are able to set up private and public networks. That is, I think, the most heavy reason why we use LoRa. Okay, so the cross-domain development kit was developed a couple of years ago to have a rapid prototyping tool. And then we realized that's not enough, because there are a lot of use cases which do not scale up that much. So we have to have a universal programmable sensor device, and that's what we developed further on. We stabilized the software structures and bring it to a bundle of 10 to easily jump into the field and use it as a product on a product maturity level. And the next thing is we set up a Iot Marketplace at Bosch, and we are able to sell ready-made solutions based on the XDK hardware for a certain use case. That's what we do here. That's what we are all fighting against. That's the long tail. It's the other way around now. Everything starts on the left-hand side with one device on the desk of the developer. That is what XDK is made for. We all want to get to figure 3, where we are above 5,000 pieces, but on that journey, we have a big customer journey, and that is what we can bring in with XDK to go with the customer through this journey. So 90% are below 1,000 pieces of all IoT use cases, and that's why there is no way we have to have something which is universal hardware, usable, reliable, certified in all countries, and then we put on the software layers which make it unique. It's the same story like PLCs in industrial automation or DDCs in building automation. That's the same story. So that is XDK based on a prototype, overcome this barrier, and most hopefully we come to that derived project above that 5,000 pieces. That is the plan, that is the goal, and that is the journey which you can go with XDK and your customer. That is in. We have 8 sensors already built in. We put everything in what comes out of our wafer fab. As I already said, there is a magnetometer in, light sensor, temperature sensor, humidity, magnetometer, gyroscope, a microphone, and an accelerometer. We put that together in a nice housing like that one. It's that size with Bluetooth connectivity, Wi-Fi connectivity, microcontroller on Cortex-M3, and we have an extension board adapter, and that's why there are no limits in that. So we can use it for nearly everything. That's why we call it's the Swiss Army knife of IoT sensoric. So that are the details if you are interested in that. Hi guys, don't worry, no problem. There are the measurement ranges on the left-hand side. And now we got the sampling rates on the right hand side, what we got out of the sensors. And there you got the already done certifications all over the world. CE, of course, we are also certified. It's not written down there, but that's what you can do there. Go to your prototyping, jump into the field, see whether it evolves. At 500 pieces, we are able to calculate an extension board. With 5,000 pieces, of course, we can go to a dedicated sensor development. We would like to do that with you together, but as I said, there is much in between, and that's what we can fill out with XDK. So potential use cases based on XDK, that is very difficult because it can be everything. I have seen everything, what you can imagine. That is one example, what we have done on an extension board base with an extension board here for a PT1000 external temperature sensor. There is a temperature sensor built in the XDK, but of course that is just for measuring the temperature of the air. And if you want to go into media or onto surfaces, you have to have an external temperature sensor, and that's what we have on our website for downloading directly. There are also the production files like the Gelder files. You can take it, produce it, and have fun with it. That's also a nice idea to see how it works and how you be able to do your own extension board development based on XDK. That is a third-party solution of LEM. LEM is a very big company in Switzerland for current and voltage measurement, and they developed a extension for XDK, and now we are able to have 12 different split cores for 12 different measurement levels of the current, up to 10 amps, up to 125 amps, and this is also working with our virtual XDK app, which is already in the app stores and download for free. So all the stuff is there and you can use it as your base, and it is also licensed that way. That means you can use it for your development or usage as a product. Okay, now the story about LoRaWAN. Why do we need LoRaWAN with XDK? In the first line, that is the DNA of Bosch Connected Devices and Solutions. We say sense, think, connect, act. So that means we have the generation of the event directly on the edge device, and that's what we can do with XDK perfectly, because people are different, they think different, and that's also in the use cases the same story. So if you want to combine your sensor signals in a different way, you can do it with XDK because it's an open system. Okay, that is now obvious. Public or private networks, exchange of a couple of kilometers already, battery lifetime very long, and we have a very, very easy integration via TTN to the Cayenne backend. That comes already with the box. We have that click to flash solution already on the workbench. You just click it and flash it to the device, and you have your first LoRa device in the network, and from that starting point you can do your own application if you would like to. These are the 8 sensors which are in, again, pressure, temperature, acoustic, humidity, magnetometer, light, the gyroscope and the accelerometer. Okay, what have we done so far with XDK? Home and building automation, that is something what we have done together with Cisco at the Cisco Innovation Center here in Berlin. So home and building automation, that is industrial monitoring, bearing experience accessoire. That means if it is worn out, you can see it on vibration or on temperature, or the best idea is to monitor the current level of the machine. And to each production step, you have your pattern for the power consumption, And if this pattern has a deviation up or down, then you know either a bearing is worn out or like a heating is not working anymore, something like that. Supply chain management, yes, we do that in intralogistic within Bosch to see whether the spare parts are arrived or not. And that is one of our partners. They set up a particle sensor with XDK and LoRaWAN to get the information about these finders a lot in Stuttgart, which is called the Feinstaubalarm, which is a very big thing because they have that valley and a lot of dust over there from the traffic and things like that. And that has been done with XDK and the LoRa extension and a finder sensor, of course, particle sensor. So how can we bring that to your desk? That's very, very easy. You buy the device, it's no problem, you can get it at DigiKey, Conrad, Mauser, whatever. It's approximately 165 euros in Germany. And there you get a link card, you download the workbench, and with the workbench you see already these ready-made solutions over there, these buttons. So you take this LoRa Things network demo, click it on, flash it to the device, and you have a starting point for your first Meta project. Meta is a programming language which is much easier with the standard C. In normal, for these embedded devices, it's the most compact code with standard C, but people which are in my age, they know what C is, but the younger guys, they want to have something which is more comfortable, and Meta is something which is closer to an easier programmable language, and that transpiles to C. So the old guys can also optimize it if they would like to do that. And then you're able to address all these 8 sensors via LoRa and bring that to your backend. And the backend is in that case via TTN, which is available here in Berlin, for example, as well, to the Cayenne backend. And then you have already your graphical user interface for that. So, very easy. So, now we are at point 4. That is the asset tracking center I have here at my desk. It's a very robust one. It's IP69K, so it's hammer-proofed. It's for rough environment, for building sites, for agriculture machines, things like that. So I took already the handle off and then I started the device. So what does that mean? Of course it's a LoRa device because here we are at the LoRaWAN conference. It's very robust, as I already demonstrated. It's IP69K. It has 3 to 10 years battery life and smart algorithms, of course. You get alerts in your backend for geofencing. That's a big thing on building sites because they lose equipment like hell. And with this device, you're able to track and trace where your stuff is gone to. And you got also an automated operation hour counter, so you see at which longitude and latitude you have had the machine working how many hours. And that is also good to get a automated maintenance book where you can see when your equipment has to go to maintenance again. That's what we do with Tracy. Okay, what we use are vibration to see whether it's idle or it's in use. The magnetometer to switch it on and to see like hydraulic valves, something like that. Within a temperature sensor to see whether there is something wrong, and the GPS receiver, of course, to see where the location of our asset is at the moment. Potential use cases for that. That is something which is a game changer really at the building site, because it is very easy to plan now where the stuff is. You see where it is, when it's idle, when it's running. And the fleet capacity is of course always limited. And now you know where it is, and you avoid a lot of searching times, and of course the asset tracking. And at building sites, there are not many things which are that robust to really go into that use cases. So digitize or die, begin with Tracy, because that one is the only one which is really robust enough to go into that use cases. The main advantages are, of course, localization, improve your processes, gain transparency, get more data, and as I already said, monitor the operating hours via vibration and temperature. And that's now really nice, because the loss of equipment at building sites is up to 10%. So think about all that heavy duty equipment and you're gonna lose 10% of that. So don't worry about the business case, it will be payback for sure. And the productivity goes up because you don't have to order new equipment, of course, and you have it available, and you don't have the search times anymore. Okay, how to get started? It's the same. Take the Tracy, mount it to your assets, and take off the handlebar, and then you got interfaces like mobile, web user interface, ERP interface, or you can do it with your own software integrator. That's also possible. So we are complete backend agnostic, so we don't care whether there is a Bosch backend or whether there is something else. So the next story is the parking lot sensor. I don't have it here because it's a little bit too big for my small desk here. It's also a LoRaWAN device. The battery lifetime is up to 5 years. And of course, you get completely new business models in smart cities. You can sell the data maybe to backends, or you can reduce your traffic jam, because up to 30% of the traffic jam in the inner circle comes from looking for a parking lot. And now you've got transparency in that, and you can see it's occupied or not. The potential use cases, e-charging, the people they charge there, but they also park there, so you want to detect whether they are parking or whether they are charging, because you want to charge the next e-vehicle and not let them park there. That's one big thing. Autonomous car parking, of course, you have to have the information from your infrastructure, which one is occupied or not. That's what you can do there. And as I already said, you are able to reduce the traffic jams in the inner circle of the cities, and you're able to sell these data-driven data model, data is the new oil, to other companies like Google Maps or something like that. So you have really a smart city because you know whether there are parking lots or not, and you're able to reduce the traffic. So search time reduction is a big thing in there. So how to get started? That's also easy in that. That's the equipment you need. We have here like the glue, the base, the sensor itself, and some equipment to bring the glue to the surface. Of course, you have to clean it a little bit up to bring the glues on. That's the glue, 2 components, and there you see the size of the sensor. Don't worry about a sensor for trucks or something like that. Nothing will happen. Glue it on. That's it. Because if you screw it to the base, then there is a read contact and it is switched on now, and you get the data of your parking lot sensor in the backend. That's it. So, call to action, request your PLS now, 10 minutes. We have the sensors over there, we have the people over there, come to our booth, and we will have a plan for your first POC. There is a bundle of 10 and also a backend solution to see the situation in the backend. So The biggest advantage of this sensor, if you compare it with others, is it is self-calibrating. All the other stuff is sometimes in a situation where you have to pre-calibrate the whole stuff, and that makes not really fun to your operators. And there is a radar sensor in, there is a magnetometer in, and there is a very clever algorithm which is really self-calibrating. That is the most benefit of this sensor. Okay, thanks a lot. Any questions to that? If there are no further questions, then all set. Thanks a lot.
Thank you.